In 2013, Union Pacific announced they would bring a big boy steam locomotive weighing 1.2 million pounds, untouched for over 50 years, back from museum exile, despite skeptics calling it engineering madness. Experts warned that rebuilding a machine with 600,000 forgotten parts could cost more than buying new diesel locomotives, destroying reputations and millions. So why attempt an impossible restoration? And how did it succeed when logic said it couldn't? Big Boy 4014 began its story in 1941. Rolling out of the American Locomotive Company's Schenectady shops as one of only 25 built for Union Pacific. At 132 feet from coupler to coupler, and tipping the scales at over 1.2 million pounds, it was a giant even among giants, designed to muscle freight trains over the steep grades of the Wasatch Mountains. With its 4-8-8-4-wheel arrangement and articulated frame, 4014 could pull more than 4,000 tons at a time, moving at speeds that kept wartime supply lines flowing and post-war commerce booming. For 2 decades, it thundered across the high country, racking up more than 1 million miles before the age of diesel engines began to close the chapter on steam. By December 1961, Union Pacific retired 4014, donating it to the Southern California chapter of the Railway and Locomotive Historical Society. On January 8, 1962, the locomotive arrived at the Rail Giants Museum in Pomona, California. There, it settled into a new kind of stillness. For over 50 years, Big Boy 4014 stood silent, a static monument to an era when American railroads ran on steam and sweat, paint faded, rust crept along the boiler and running gear. Visitors could climb up to the cab, peer at the gauges, and imagine the heat and thunder that once filled the air, but nothing moved. The firebox stayed cold. The rods and pistons froze in place, their intricate joints locked by time. Decades passed. The world changed around 4014. Diesel and electric trains replaced steam across the continent. The skills needed to build and maintain a machine of this size and complexity faded from everyday memory. For most, Big Boy 4014 was a relic. Impressive, yes, but forever rooted in the past. Few believed anything so massive, so specialized, and so long dormant could ever run again. The locomotive became a fixture in Pomona, a favorite for rail fans and school groups, but also a reminder of how quickly even the mightiest machines can slip from purpose to nostalgia. Its sheer size, its history, and its long sleep in the California sun set the stage for a question no one seriously asked for half a century. Could a legend like this ever return to life? Union Pacific's announcement in 2013 landed like a thunderclap in the railroading world. The company had quietly reacquired Big Boy 4014 from the Rail Giants Museum, trading a diesel locomotive and a caboose to bring the behemoth back under its banner. But this was not just a gesture for nostalgia. Behind closed doors in Omaha, executives weighed the risks and rewards. The plan was to restore the world's largest steam locomotive in time for the 150th anniversary of the Transcontinental Railroad, a public relations spectacle, a living tribute to American engineering, and a gamble on the company's heritage brand. What they did not disclose was just how much they were willing to spend. No official budget ever surfaced. Union Pacific kept the financial details locked away, fueling rumors and speculation among industry insiders. Rail analysts tried to do the math: a multi-year restoration, a crew of skilled craftsmen, custom fabricated parts, and a locomotive with over 600,000 individual components, many of which had not been manufactured since the 1940s. The estimates whispered through the rail community were staggering. Enough to buy several brand new diesel locomotives, each with a price tag of $3 to $5 million apiece. But this was never about cost efficiency. Bringing 4014 back to life would require resources, patience, and a willingness to accept that failure was a real possibility. Skepticism bubbled up almost instantly. Industry veterans and technical experts questioned the wisdom of pouring millions into a steam engine that had been silent for half a century. Some pointed to the sheer complexity, hundreds of thousands of parts, each one a potential obstacle. Others doubted whether the specialized skills and lost manufacturing knowledge from the 1940s could be recovered at all. A rail historian summed it up bluntly: "You can't just throw money at a big boy and expect it to move again." The metallurgy alone is a nightmare. For Union Pacific, the stakes went far beyond dollars. If the restoration failed, the company risked public embarrassment and a blow to its reputation as a steward of railroad history. But if it worked, 4014 would become a rolling symbol of perseverance and pride, a living, breathing link to the golden age of American railroading. The decision was set. The world would soon watch as Union Pacific's bet played out in full view, with the fate of a 1.2 million pound legend hanging in the balance. The first inspection in Cheyenne revealed a machine more ghost than locomotive. Decades of exposure had chewed through steel and iron, leaving corrosion in places no museum visitor ever saw. On the boiler, rust had eaten into the stay bolts, hundreds of them, each one a vital anchor holding the pressure vessel together. Nearly every stay bolt in the firebox showed signs of advanced decay, some so fragile they snapped at the touch. The audit tallied over 500 stay bolts needing replacement, a task that alone would have grounded most restoration attempts. Elsewhere, the damage went beyond surface rust. The running gear's intricate maze of rods, pins, and bearings had seized solid, their lubrication long since dried to dust. When workers pulled back the inspection plates, they found pitted journals and flaked Babbitt metal, the kind of wear that only years of neglect can produce. The superheater units, crucial for boosting steam temperature, were so caked with scale and corrosion that they had to be torched out in pieces. Mud ring segments at the base of the boiler, designed to contain the fiercest heat, had warped and cracked. Some sections were missing entirely, lost to souvenir hunters or decades of careless exposure. The cab was hardly better. Gauges had clouded over. Brass fittings were stripped, and the original wiring had been gnawed by rodents. Thieves and well-meaning collectors had made off with everything from valve handles to builder's plates. Even the fasteners, nuts, bolts, and rivets posed a problem. Many were manufactured to 1940s standards, with thread pitches and alloys that no modern supplier could match off the shelf. Every missing part meant hours of research, pattern making, or, in some cases, tracking down a craftsman who still remembered how to cut a left-handed thread by hand. For all its size, Big Boy 4014 was now a puzzle with hundreds of missing pieces. The firebox grates, once designed for coal, had been removed and donated to another locomotive years earlier. The brake system was incomplete, with key valves and cylinders either frozen or cannibalized. Even the massive driving wheels showed deep grooves and flat spots, evidence of years spent motionless under their own weight. Each system, from the air compressor to the feed water heater, presented a new set of seemingly unsolvable riddles. Corrosion reports painted a grim picture. Some steel plates had lost a quarter of their original thickness. Staybolt failure rates were among the highest ever recorded on a surviving steam locomotive. No one could say for sure if the original boiler metal would hold up under pressure, or if the frame itself was still true after so many years of settling into concrete. This was not just a restoration. It was a rescue mission at the edge of what was possible, with the odds stacked higher every time another missing or ruined part came to light. Inside the Cheyenne steam shop, the work began with a challenge few living machinists had ever faced: how to revive the lost craft of building and repairing a locomotive the size of a small building. The team, led by Dickens, pored over faded Alco blueprints and battered technical manuals, searching for clues to the original metallurgy and assembly. Most of the steel in the boiler and frame of 4014 had been forged in the 1940s. using recipes and techniques that had all but vanished from modern industry. The restoration demanded more than just standard repairs. It meant resurrecting a kind of industrial alchemy. Welding became the heart of the operation. The shop's boilermakers, some with decades of experience, had to relearn how to lay down beads on carbon steel plates nearly 3 inches thick. The original welds, laid by craftsmen during the Depression, had a signature look and structure, shaped by the tools and filler metals of their time. To match them, the crew experimented with vintage weld rods, preheating cycles, and slow cooling methods. Each patch on the boiler, each seam where new steel met old, had to be as strong as the original or better. Don Crerar and James Thompson spent days on the mud ring, welding in new sections where acidic ash had eaten through. 8 hours might go into a single hole, machining, welding, rethreading, and sealing until the surface was flawless. Modern technology joined the revival. Where the original builders had used wooden forms and hand hammers, the Cheyenne team turned to 3-dimensional scanning and CAD modeling. They scanned the battered boiler shells and produced digital blueprints, then designed custom dies, male and female forms welded together, to press new boiler plates into the exact curves and dimensions of 4014. These dies allowed the shop to form elephant ear patches and mud ring segments that fit within a fraction of a millimeter, preserving both the shape and the integrity of the pressure vessel. The team used digital tools to match old geometry with modern precision. Reverse engineering extended to every corner of the locomotive. When original parts could not be sourced, machinists used archival drawings and digital models to fabricate replacements from raw steel. Some components, like the flexible steam pipes for the articulated frame, demanded a blend of hand-fitting and computer-guided precision. Others, such as valve handles and custom fasteners, were recreated by tracing the ghostly outlines left behind in the cab. The firebox, once designed for coal, required a complete reimagining. Dickens pushed for a conversion to number 5 fuel oil, a move that drew skepticism from steam veterans. The new oil burner had to atomize fuel into a fine mist and distribute it evenly across a firebox never meant for anything but chunks of Wyoming coal. The team built a custom burner, tested spray patterns, and tuned the system until it delivered steady, even heat, solving a problem that had stumped engineers for decades. As the months ticked by, the shop floor filled with the sounds of progress. The hiss of welding torches, the clang of formed steel, the whir of digital calipers checking tolerances. Each successful repair, each custom part, brought 4014 closer to a state of readiness no one outside Cheyenne had thought possible. The locomotive was no longer a collection of missing pieces and corroded dreams. Under Dickens's watch, it was becoming whole again, piece by piece, weld by weld, until the day would come when the boiler would face its ultimate test. On a cool April morning in 2014, the quiet streets of Pomona, California erupted with excitement. Big Boy 4014, dormant for over half a century, was about to move. The operation began with a challenge that would have stumped most heavy haul crews. The locomotive sat landlocked inside the Rail Giants Museum, hemmed in by buildings and tight curves. Standard rail lines could not reach it. Instead, workers laid down temporary 40-foot track panels, leapfrogging each section forward as the engine crawled along. It was a slow-motion dance: lift, place, roll, repeat, performed under the watchful eyes of hundreds of onlookers and rail enthusiasts who lined the fences, cameras in hand. Once clear of the museum grounds, the journey ramped up in scale. The route stretched nearly 1,400 miles to Cheyenne, Wyoming, cutting through city streets, over freeways, and across the Mojave Desert. Each mile demanded careful planning. Overpasses and tunnels were measured and remeasured, with some clearances so tight that crews had to remove signal arms and trim trees just to squeeze the giant through. At every crossing, police and volunteers held back crowds eager to glimpse the sleeping giant on the move. Social media lit up with photos and videos as the convoy passed, turning the relocation into a viral event. But the spectacle was not just for show. The move itself was a test of logistics and nerve. Each segment of the route required coordination with local authorities, utility companies, and Union Pacific dispatchers. In some towns, traffic stopped for hours as Big Boy inched past at walking speed, pulled by a pair of diesel locomotives, and shadowed by a caravan of support vehicles. The leapfrog method continued wherever permanent rail was missing, with crews hustling to lay track ahead of the engine and pick it up behind. At night, the convoy paused in rail yards, where mechanics checked bearings and lubricated moving parts, making sure nothing seized up on the long haul. By the time 4014 crossed into Wyoming, it had become a rolling headline, a living piece of history drawing crowds at every whistle stop. The final miles into Cheyenne felt less like a delivery and more like a homecoming parade. For the first time since 1961, Big Boy was back in a working shop, ready for the real tests to begin. Federal inspectors arrived in Cheyenne with clipboards, checklists, and a mandate no shortcuts. The heart of Big Boy 4014, the original 1941 boiler, had to meet a standard its builders never imagined. Every weld, every stay bolt, every patch of steel was scrutinized using tools that didn't exist when the locomotive was new. Ultrasonic probes mapped the thickness of boiler plates, searching for hidden pockets of corrosion. Radiography revealed the integrity of seams buried deep within the pressure vessel. Where the steel had thinned too much, it was cut out and replaced, and where welds looked questionable, they were ground back and redone. The boiler's maximum allowable working pressure, set at 300 pounds per square inch, became the line between history and disaster. The moment of truth came with the hydrostatic test. The crew filled the boiler with warm water and slowly pressurized it, not to 300 pounds per square inch, but to 450 pounds per square inch, a full 1.5 times the operating limit. This was the standard set by the Federal Railroad Administration, and there could be no exceptions. As the pressure climbed, every eye in the shop locked onto the gauge. Water seeped from a few threaded joints, but the old steel held. No catastrophic failures, no sudden cracks. Inspectors checked for drops in pressure, for any sign of weakness. The boiler passed. With federal approval in hand, the team prepared for the first live fire test. On April 9, 2019, fuel oil hissed into the firebox. Ed Dickens opened the atomizer, and a torch lit the first flame inside 4014 in nearly 6 decades. Steam pressure crept upward as the fire took hold, warming the massive steel shell. The gauge needle steadied at 300 pounds per square inch. Pipes began to vibrate, valves rattled, and a low, familiar rumble filled the shop. For a moment, the doubters' voices faded beneath the sound of steam building in a vessel that had defied both time and skepticism. Big Boy 4014 was alive again, not as a museum piece, but as a certified, working locomotive, proven safe by every modern test and powered by the same force that once drove it across the continent. Today, Big Boy 4014 thunders across months modern rails, a living contradiction in an age of automation. Its rebirth proves forgotten skills can still outpace obsolescence, even when the world moves on. As industries rush to replace rather than restore, the lesson is clear. Some legacies aren't meant to be mothballed. Sometimes it takes the impossible to remind us what is worth preserving. What would you fight to bring back?